Cool. Yeah, thank you. Start with a caveat. I am the wrong person to be giving this talk. So I will share a lot of what we have played with the IPC so far and kind of what our experiences are. So the first caveat is most of this work was led by Sander on my team and Carson on my team, neither of whom are here, but I do my best to capture what they've done and can speak to it and try to answer some questions. The other caveat is that a lot of this exploration was done in the spring, so I think a lot of things have obviously changed since then. So I'll like bring up some questions and some needs and things like that, and many of them have already been probably resolved, or at least are on the roadmap. So a quick brief, what's Tablelland? So Tablelland is simply if you're writing an application and you want your program to be able to define access control rules on chain. So it exists on multiple different chains. It's simply a Solidity smart contract where you can own tables in a database, and then you can use other smart contracts to write the access control rules for how the data in those tables will change. So it's really good for several different use cases. But it's missing a lot of things that are kind of in our vision for where it could go. There's no sort of right now, the way that Tablelland runs is there's a single provider that's actually materializing the state from all these different smart contracts into actual databases where you can query them. And we want that to move into a multi-provider world. And there's a few different configurations that we can imagine how that will happen. Also, data storage is something that we want to solve, and obviously Filecoin is what we're trying to do there. And then it has some scaling issues. It doesn't solve all the use cases that we want to solve, because right now, every transaction to your database that is changing data needs to go through a smart contract on one of these chains that we support. But we're starting to hit use cases from users that don't really need that specific flow, but want something else. And I'm going to get into that and kind of breaking up the Tablelland stack in an interesting way. So yeah, how do we handle data storage and verifiability? What's our solution for general kind of large scale online data? And then how do we kind of connect this to the verifiability and POREP abilities of Filecoin, and then consensus over the whole thing. So one cool thing in Tablelland is because of all those transactions happening on all these different L1s, consensus actually exists in a few different conversations, but generally consensus for what those changes should be coming from is already handled by the chains that we're connected to. So I'm going to walk through an experiment that we did, which was to say, we saw what IPC was doing. We got really excited. We said, okay, Tablelland should totally exist like this. So let's go full metal. Let's just try the whole thing. So Tablelland, what we actually do is we run SQLite, and there were a lot of cool reasons why we did that. So we started asking the question, could we just run SQLite in IPC, or in actors that are running on an IPC subnet, and enable transaction-based updates to those databases in the subnet, and then allow you to just do public row-level reads from that database directly. So yeah, this is what we did in the spring. So we did a little bit of R&D with a Fendermint-powered FVM, and I actually have a slide of links so you can dig into some of what we did there. And we developed this full FVM actor that runs a full SQLite node, the virtual file system-based block store. And the reason that piece is cool is I'll have a link to a couple things about that, but the way SQLite stores data behind the scenes is a paging-based database. So all data is sort of logically put into these different page files. And so if you have the index and the page files, you know where to go get your rows. But we did some cool work there to say, like, what if that data was just a DAG? And so that the data itself could be distributed across a network like IPFS or Filecoin. And what's really cool about that in this world is like, if you imagine our subnet running these SQLite actors, and a change comes in, that change doesn't change the whole database, it just changes a page. And so you can just stream page-based updates to whatever persistence layer exists. And so then the actor exposes this API for executing the SQL statements or returning responses. So this is an interesting note for this experiment that we did is actually reading the database was a blockchain transaction. So you submit the read request and it's returned back. It returns back the information. And so the outcomes of this experiment, I don't think I can show the video here, but I'll share the link to a video. But what we did is, if you're familiar with web mapping, it's a really cool little example that we did. So the way that web maps have traditionally worked is like if you look at a map of the world. So if you go to like Google Maps and you zoom way back out to the world, to like the whole world view, what traditionally you'd been looking at would have been 4 PNGs that were stitched together. And then if you zoom in one level, each of those PNGs cuts up into 4 more. And so if you zoom in like 20 levels, you're looking at billions of tiles. But because you're only looking at a small window of it, you only need to fetch 4. Well, if you have a large screen, more than that. But and that's how maps have worked pretty efficiently for the last decade and a half. And that's like a really simple explanation of that. Now there are vector tiles that do like in-browser rendering of that stuff and like optimizations for like between zoom levels and things like that. But what you can imagine is that every tile that you might pull essentially has a predictable address, right? So it's like the zoom level plus like a global XY at that zoom level. So you can say like what's the ZXY value and know exactly what PNG or vector tile or whatever you need to pull in order to render it on your screen. And so traditionally the way that like the kind of like state of the art for serving that kind of data 10 years ago was to just actually put it all in a SQLite file. So you just create a key value store in SQLite where the key is that address and the value is the blob of the PNG or the vector tile or whatever it is. There's more state-of-the-art ways of doing that now where you just store like a giant flat file and you do range requests on S3. But the SQLite database has some nice benefits to it. And then if you think about this data, it has some interesting properties of read and write. So people read it a ton and people write it in less frequently. And actually, if you're maintaining a map data set, you don't generally like re-render all of the tiles. Like you imagine there's road construction and it's only going to affect a set of tiles up through the zoom levels, and that road isn't probably even rendered at high enough zooms, so it doesn't even affect those tiles. And you imagine like oceans are just a lot of repeated blues and things like that. So a lot of optimizations inside of there, but it's essentially just a SQL database that you need to run a query, get back the data that's behind it. And so I'll share a link to this, but we have a demo of essentially a subnet running a SQLite database that contains a tile set, and then it's serving those tiles based on requests. And like I said, this was like full metal. It was saying like, what could this do? And you can start imagining what some of the challenges are here around what is the transaction throughput of a subnet, and being able to actually request that many tiles becomes limiting. So you can't actually imagine in a single layer subnet being able to support a use case like this without, again, like just throwing another layer of caching or something like that on top of it. But what we realized along the way is that we had this bucket of wish lists for IPC, and we realized that we could break this stack up into a couple of new components, one of which seems much more tractable to start, and then the second one sticking to this idea, how do you do the full SQL execution alongside the first problem. And so the first problem that we identified through this is actually once you get those SQL statements and you change the database, you're changing the state of those page files. You need to stream those page files someplace so that people can get them if they want to replicate this database. And SQLite is, again, really cool because you could replicate it a lot of places, including the browser. And you could replicate a really large database in the browser and only pull optimistically the page files you need to read. So there's a lot of cool things you could do if you had that. And so we started breaking up our experiment and saying, well, what if we put aside the full SQLite engine and we just say, can we do data availability? Can we create a fairly generic subnet that will take namespace or create namespaces on demand and allow you to update an append-only log of what is the current state of that namespace? And so that became our test number 2 that we're more actively working through now. And so focusing on this data availability of streaming data. So this, again, has a really cool database tie-in. And so the first place that we started realizing that this approach might be interesting to a lot of use cases is, like I mentioned that we use SQLite inside of our internal stack, but we started talking to a lot of potential customers about what their database stack was. And you can imagine it's like overwhelmingly Postgres. So converting them to a SQLite flavor SQL is just overhead. Converting them to a different database is overhead. But what if we could just connect their production databases that they're already using into a Filecoin world, making that data available and making it so that they can replicate it on different nodes, other people can pull it, and it has and it eventually resolves onto Filecoin deals so that it has long-term storage and pro-rep and all of that good stuff. So Basin started trying to think through that idea of, and the really cool thing about Postgres and most production databases is they have good support for basically the first step of that, which is how do you take a stream of just the data that's changed. And so in Postgres, you can connect to the wall API. SQLite has similar. You can connect to the page updates. I forgot to mention on the SQLite about the paging. That paging data, if you can rip it out of SQLite and put it into a DAG form, it becomes really cool too. And so we actually have a cool write-up. I'll share a link on where we did just that. But so you can do that in SQLite. You can do that in a lot of different databases. They have this idea of like how do you connect to the stream of updates in an efficient way, and they have different reasons for having that API, and it can be for backup and it can be for replication. But so can we create an endpoint that just allows any production database to start doing that? And if you can do that, you don't have to think just in databases. And so we started talking to different potential customers and started building a basic MVP for a project called WeatherXM. And so WeatherXM, their data is database-like, but it's actually just a giant stream of Parquet files. And so can we take that stream and basically be able to report what is the latest state of their data? And they have two requirements of that data. They want it to be immediately available back to their network within a reasonable amount of time. So what they want is the last 24 hours of data to be able to get it so that they can calculate rewards on their network. But the rest of their data, they don't really need it in the immediate term, but they want it available long term because that is actually the value of the network. They want to be able to sell access to that data. And so that's a really beautiful setup here where if we have an availability layer for the last 24 hours of data, but then we have cold storage on Filecoin. And so you can kind of see where we're going in this design. But also the Tablelland protocol that I've already been talking through needs this exactly as well. So where are we putting this data and how do we get it on Filecoin? Well, we actually just need the latest data to be available immediately for replication across Tablelland providers, but then long-term data, we want people to be able to find the sequence of changes to that data. And so making that resolve onto Filecoin is really interesting. But there's a lot of other use cases. We're talking to a couple different Protocol Labs teams, for example, that are generating different data streams on top of the network that actually aren't on the chain. That can be valuable for a lot of different use cases, like DeFi, for example. You could imagine DeFi protocols wanting to be able to read like things like reputation. Well, that reputation could exist in a globally accessible database that actually lives on Filecoin. So the IPC designs that we're working through is trying. So one thing that we realized is if you shove a SQLite actor into IPC, you're not going to want a really big subnet, right? You're not going to want 100 nodes all trying to replicate the exact same state of all the different namespace databases across that whole network. So can we just start with small subnets? Can we actually create? And we don't have a token model yet. We're like really trying to focus on the user and how they use these things right now. And so we don't need to rush into saying like, how do we build a fully open subnet that just anybody can run and is permissionless and everybody can do it at first. But instead, can we create a small subnet where a few different collaborators can run nodes and support this system and support these streaming endpoints that are really flexible for databases or Parquet files or whatever it is that you want to stream into Filecoin, but have immediate accessibility for them across your network or your protocol, and namespace those things. So similar to S3, I've been really interested in something that S3 doesn't quite have, which is TTL of this data. So we probably don't want the namespaces to have to maintain all of the data that comes into them forever. That's what actually getting different storage deals to do would be better for. But you could imagine TTL, and TTL has like a lot of different settings in in CDNs, but you could imagine a TTL0 where we don't even store the data, but we just get it into your index. Or you could imagine like a TTL -1, I think, which is basically you pay for it to actually keep it hot all the time. And then keeping that idea of the ACL per namespace. So doing something like you can, or doing something like full smart contracts directly in this subnet that then people can define the access control rules for their namespace. So I'm here. I just wanted to share a bunch of that with you, and I can answer any questions. But what I came actually this week really to learn was what is the IPC roadmap, because you can see in both of these different layers of Tablelland, the data availability layer that we're tackling now, and when we get back to how do we run the full database in these permissionless nodes, we kind of want to just know better what's in and what's out for the IPC roadmap. But I'm also here if you hear either of those use cases or either of those designs. I want to talk to more people that are trying to figure out how to do these dynamic data sets with persistence and availability, and make sure that we're building for real use cases. Right now, we're talking to WeatherXM. Tablelland has this use case. I believe that other database networks have this use case. So I'm actually really eager to talk to like Ceramic and Polybase and those other teams that are trying to figure this out and see if we can align to actually a shared underlying substrate for this data, which would be very cool. But if you know others, I'd love to talk to them. And that's it. Oh, I actually changed too. We have a Substack now. It's just Substack Tablelland, which are our week notes, which are all just like research and developer notes. And a lot of it is about IPC and other protocol design things. So definitely invite you to check that out.
All right.